Hello YouTube, for today's video I'm going to teach you force and motion. Force is a push or pull which makes an object move. For motion, it's the effect exerted to an object by pushing, lifting, or twisting. What can force do to an object? Well, number one, it can make the object move or stop moving. It can Number two, it can speed motion or slow down motion. Number three, it can change the direction of motion. So, number one means if, you know, if, if like this, you're here, a rock, and then if you have enough strength, you can push that, then motion will stop moving. Motion will stop moving. Motion will stop moving. Or if you see a boulder, then you push that, it will move there. And number two, it can speed motion or slow down motion. So like this. Motion. Okay, here it goes. Like this. You're in a car. Then you're driving. Then you can make it fast by stepping. And number three, it can change the direction of motion. If you push that, it will go to a direction where it goes, or there. It doesn't matter. So it will go where the position where you push it. So next, forces acting on an object. So unbalanced force. The forces acting opposite on each other are balanced, are unbalanced, are not equal. There is motion. So it means and here's another one. The forces on opposite sides are unbalanced or unequal. Direction of motion the stronger place. Unbalanced forces cause motion. So for example, you're playing tag of war with other people. So here, your group is this one. So there's a group here. So group 1 has 6, while group 2 has 5. So it's unequal. So the one that has the biggest amount of teammates on the group, this group 1 would win. It would win. And next, balanced motion. So balanced motion is the forces acting opposite on each other are equal. There is no motion. The force on opposite sides are balanced or equal. Balanced forces are acting on an object, causes no motion. So like this, group 1, group 2 has 6. This other guy has 6. So if they pull, there's no motion. They're in the same. the teammates amount are the same, is the same amount of teammates in each group. So next one is inertia. Inertia, friction, and other forces. So inertia at rest, where of an so here the tendency of an object at rest unless action is on an uncancelled force. So that means if you stop an object from moving, it will stop. You will stop the object from moving, and it will rest. For example, you stop a ball from moving, and then it's stopped. It stopped. It stopped. So next is inertia in motion. So it's moving. The ball's moving. Then the ball's moving like that. So inertia in motion, the tendency of an object to continue in motion unless is stopped by an unbalanced force. So if like this, you kick a ball and it goes very fast, then a soccer goalie stopped the ball from moving, from getting into the goal. So action. So friction, the force that opposes motion. Action releases pairs. So action, reaction pairs. So for example, man in a boat, dog on boy on skate. Sorry, I forgot the sentence, so I thought it was dog, but it was boy on skate. So action, reaction principle for every action, there is an equal and opposite reaction measuring force. So next is gravitational force, measured by the weight of an object. The pull the earth exerts on all objects near it is one kind of a force. Newton. So Newton, the substance, their unit of measuring force. It is named after Isaac Newton, who he's a physicist that studied. So I think I can draw him. She's wearing a wig. Wait. So this is how he looks like. This is how he looks like. So he used so I will discuss about Isaac Newton on another video. So this is how he might look like. So back on motion. So next one is here the billet of the delt of mass and weight. So here, mass of an object. So here's a list. So this is kg, and this is grams, and this is Newton. So 1 kilogram equals to 1,000, and then the Newton would be 10. So if it's 1.5, that would be 500 grams. So the Newton will be 5. So 1/4 would be 250 grams, and the Newton will be 2. So last but not least is 1/10. So it would be 100 grams, then the Newton would be 1. So moving on. Force, mass, acceleration. Mass of a quantity of matter is an object. Which has a greater mass? A. Table or a chair. B. Truck or a car. So here. So here. So force equals M times A. So where F is the amount equals the amount of force of force. Next is mass. Next is M. So next is M. M equals to mass of an object. Mass of an object. So next is A. It equals to acceleration. So I can acceleration centimeter cn per second. So next one is this. Next one is mass equals F over force over mass equals to force over acceleration. So where mass of an object, so M equals mass of an object, F is the amount of force, acceleration is acceleration. Next is acceleration. So if like this, mass equals force divided by acceleration. So I'm gonna show you another version of this. So next up is A. Acceleration equals to Fm. Acceleration, so it's the same. So acceleration equals the force divided by mass. So next is the other. So next is the types of motion. So Motion refers to change in position. Types of motion, one of those is linear motion. So it moves in a straight line. So if you're driving in the road, it's maybe a straight line. Next is falling objects like rain and what? Dripping water. It's running water. Yeah, from a faucet. So next is circular motion, movement of an object around a curve. So, for example, a car moving up a mountain. So, this is up a mountain. Then, a car may be moving up in a ramp. So, next up, it's rotary motion of an object on its axis. Okay, so rotary motion of an object on its axis. So, for example, a CD spinning, or a record spinning, then it will produce sound, right? It's recording. And next is the next example is moving a row. So next is moving a spinning top. So if you use the spinning top, it will go spinning. That's why it's called spinning top. Next is simple harmony motion, movement of an object in up and down, to and from, or vibration of an object. Like this, playing a yo-yo, it goes up and down. It goes up and down, it spins. So next, strumming a guitar. And next one is measuring, reading, and analyzing distance. So it's gonna be like, it's the same from forces, mass, and acceleration last time. So here's the motion. It can be described by the distance or length of an object or person has covered, and by the time it takes that object or person to cover the distance or length. Next, and then distance is a length traveled by an object. It is expressed in centimeter, meter, centimeter, or kilometer. Next is time, usually expressed in seconds, minutes, or hour. It is how lengthening on object travel. So next is speed, refers to the quantity and tells how fast of or slow an object or person. So is speed. So this is how it is. So speed equals, so it would so A will be replaced by speed, acceleration will be replaced by speed, equals distance and time. So it divides those two numbers and you get something called speed or velocity. So next up is speed can be expressed in kilometers per hour, or km/h, or kmph, like that. So meter is used to express short distances. Next is kilometer, used to express long distances. So meter is for short distances, and kilometer So, sorry for that. So here, um, so we're in Word. We're in Word. I can't, so there's no space, so I have to transfer here. And so here, so example, speed. So so next is distance. Distance distance equals to speed times time. So speed equals to speed. Oops, it was distance. Distance equals speed times time. Oops, wrong spelling. Distance equals speed times time. And so, for example, so next is time. So next is time. So next is time equals distance. Divided by time. So if you're gonna compute time, you have to divide distance and time. So I hope you enjoyed this video. So be sure to like and subscribe, and I'll see you in the next video. I hope you enjoy. Bye.